Let's do this, everybody. More arithmetic sequences we're going to be working with in this video here. Now, you've already learned how to find the general formula for an arithmetic sequence and a little bit of how to use that, but what we're going to be doing today is using that a little bit more. You're going to use a general formula to find various information for an arithmetic sequence. And there's lots of different types of things you can be asked, and you will see what those different types of things are as we go through the video. Want to start with this question, how many common differences, which the question doesn't make any sense yet, but I want to instill a pretty simple idea in your head about how many common differences there are between any two terms in an arithmetic sequence. Alright, now one thing that we've already established in the previous lesson is that if you want to know how many common differences there are between any term, say the 17th term and the first term, well, there's always going to be one fewer common difference than the term number that you're trying to find. So the 17th term equals the first term plus 16 common differences. Or the 108th term would equal the first term plus 107 common differences. But you can figure out how many common differences there are between any two terms. It doesn't have to be between a term and the first term. And it's a very simple thing. Let's say that I wanted to know how many common differences there are between the 13th term and the 5th term. Well, all you really have to do to determine that is figure out what's the difference between the term numbers. Okay? Like here, wasn't 17 minus 1 16? 108 minus 1 is 107. Well, here, let's do 13 minus 5. And this is logical, I believe. If you add 8 common differences to the 5th term, it tells you what the 13th term is. All right? If I want to know how many common differences away the 20th term is from the 3rd term, well, it's going to be 17 common differences. Because that's the difference in the term numbers here. Now, hopefully that seems like common sense, because I kind of feel like it is, but it's going to be very helpful common sense for the next couple of problems that we're going to work on. And here's one of those. In an arithmetic sequence, the 22nd term equals 108, and the 31st term equals 45. Two things we're going to do. We're going to find the common difference, and we're going to find the first term of that sequence. Okay, now here's where what I was just showing you is going to come into play. We can find the common difference between for this arithmetic sequence very easily because we know how many common differences there are between the 22nd term and the 31st term. You know there's 9 common differences there. So let me write this expression or this equation here, that the 31st term use of 31 is equal to the 22nd term use of 22 plus 9 common differences. What will I do with that? Well, I know the values of each of these two terms, and so I will substitute those values into this equation that I made, this general formula, and that's going to make this 45 is equal to 108 plus 9d. And now I can figure out what the number of common differences, or what the common difference is, just by subtracting 108 and then dividing by 9. All right, and if you subtract 108 and then you divide by 9, you're going to find out that the common difference is -7. All right, and then to find the first term, well, we could use either of these two terms right here along with the common difference to find out what the first term is. Let's say we use the 31st term. All right, the 31st term would be equal to the first term plus 30 common differences, wouldn't it? Which means that 45 would be equal to the first term. This thing is being really weird. It is equal to the first term plus 30 times -7. All right, and so if you'll just add basically 210 to both sides, that'll cancel out that 30 times -7, and it'll tell you that the first term in that sequence is 255. Fairly easy, right? Okay, I would recommend that you try this next one on your own and then just use me to check your work. It's a similar problem, asking a slightly different question. I'm asking you this time to find the 27th term of an arithmetic sequence if you know the 17th term and you know the 39th term. And you will need to know the common difference in order to make that happen. So try it out. Did you start here? The 39th term and the 17th term are related because you can add the common difference 22 times to the 17th term in order to get the 39th term. Now substitute. Then subtract 13 and divide by 22, and you find, to three significant figures anyway, that the common difference is about 0.218. And now to find the 27th term, you just have to either use the 17th term or the 39th term. I would recommend using the 17th term. And you can say the 27th term is the 17th term plus 10 common differences. Substitute our common difference in for D, and you'll find that 27th term that we're looking for. I'm going to get about 15.2. All right, we're going to try a couple more things with arithmetic sequences. Really the same idea several times. And here's what that idea is. What I would like you to be able to do is I'd like you to be able to find out in an arithmetic sequence the value of a term that is between two other terms. If you know the terms sandwiching it, what is the value of that term? We're going to find the value of x in this arithmetic sequence. Now really these don't have to be the first, second, and third term in the sequence, but for us they are. They could have been the 19th, 20th, and 21st terms, and we would do this exact same thing. I want you to see the relationships between any three consecutive terms in this kind of sequence. Now I'm going to show you the quick and easy way of doing this, but I want to describe to you why it works out that way. I think you would agree with me that the second term is the first term plus one common difference, and I'll tell you what, I'm going to take a different train of thought than that. Hold up. Let's just think of this way. The difference between any consecutive terms has to be equal to one another, right? So we could make this equation. We know the difference between the second and first terms, x minus 28, would have to be equal to the difference between the third term and the second term, negative 10 minus x. If those common differences aren't equal, this is not an arithmetic sequence. Well, we were told it's an arithmetic sequence, so we know that those the difference between these terms and these terms is equal to one another, and this is how you find those differences. So I made that equation, and then I can say that 2x is equal to 18, so x is equal to 9. And indeed, if you just kind of substitute that value of x into the sequence, you can tell that you do have an arithmetic sequence, because if you had the sequence 28, 9, negative 10, you would have a common difference of negative 19 between the terms, both pairs of terms, so it works out. All right, same idea in part B. We're going to show that the difference between the first pair of terms equals the difference between the second pair of terms, and then using that, you can find the value of x. All right, so second term minus first term, third term minus second term, those differences are equal. You'll end up with 2x is equal to 48 fifths, not 48 fifths, but 78 fifths. And then in this case, let's multiply both sides by 1/2, so that'll make this fraction easier to handle. And half of 78 fifths is going to be 39 fifths. And then I'm just showing you here again that the pattern works, doesn't it? There's a common difference of 8 fifths if you have 31 fifths, 39 fifths, 47 fifths. Now one more thing. Those of you that are more astute may notice that really what I ended up doing in each of these equations that I solved was adding the first and the third term together and then dividing by 2, right? 28 plus negative 10 is 18. 18 divided by 2 is 9. 31 fifths plus 47 fifths is 78 fifths. 78 fifths divided by 2 is 39 fifths. The number in the middle of two other terms in an arithmetic sequence is simply the average of those two numbers. That is a pretty easy way of thinking about this as well. All right, changing the problem up a little bit, I'm making the middle term a constant value, and the first and the third terms, I'm making those into variables. We can solve this the same way though. Go ahead and see if you can find x in part C, then unpause the video, check your work, and then see if you can do the same for part D. All right, there's the equation where it's the second term minus the first term equals the third term minus the second term. And let's clean that up and solve. And you can follow the algebra, check for yourself, but you end up with x is equal to -5. Now again, just kind of checking to make sure that it made an arithmetic sequence. If x was -5, then you would have -11, comma, -4, comma, 3. And you can see how there's a common difference of 7 there, so indeed that did make an arithmetic sequence. All right, you're going to end up with a quadratic equation in part D, and you're going to end up with 2 different answers actually that will work, but I still need you to find them. Go for it. There's me setting the differences between each pair of terms equal to one another. And we've cleaned it up, and now we're going to set the equation equal to 0 because it is quadratic. Alright, now 2 things. We're going to try to make this a little bit easier to work with by noticing that every term here is divisible by 2. So we'll make that 0 equals x squared plus 2x plus 35. Alright, and if we could factor, we would factor, but that's not a factorable expression. So you're going to use quadratic formula, most likely, in order to find out what the value of x is. And this kind of thing happens from time to time. I'll trust that you know how to get the numbers from the quadratic formula to get this right here. We're taking the square root of a negative number, aren't we? So there's not going to be any real number that will make this equation right over here true. So no real solutions. And really what that means for us, and this rarely happens, you'll mostly get real solutions, but that means it's impossible to get an arithmetic sequence with the values 4x, -32, and then 2x squared plus 6. Alright, you'll learn plenty about how to use arithmetic sequences at this point. Next up are geometric sequences. As always, appreciate your attention. See ya.